There are two requirements that should be met for work to be done. 1. Force needs to be applied on the object. 2. The object needs to be displaced. Now let's say a constant force is applied on an object and the object is displaced through a distance s in the direction of the force. Understand what I said. The work is done on an object through a force which is constant. What does that mean? To put it in simple words, force applied doesn't change its magnitude or its direction, and the object is displaced in the direction of the force. Now, how can we make this into a formula? It's very simple. Work done is the product of force and displacement. It equals F, which is the constant force, times S, which is the displacement in the direction of the force. So W equals F times S. Thus, the magnitude of the force multiplied by the distance moved in the direction of the force is equal to work done by that force acting on an object. Remember, work has only magnitude and no direction. Let's try an exercise to get a clear understanding of this concept. A cat sits on a table. He notices a remote control there. Like all feline creatures, he tries to push the remote control to a certain distance and is satisfied after doing the deed. Now, let's see where our problem solving comes into this. Let's say the cat applied 10 Newton of force on the remote control and the displacement is 1 meter in the direction of the force. What is the work done by the cat in this case? Since the force acts on the object through displacement, we multiply the value of the force with the value of displacement. So multiply 10 with 1 and we get 10 Newton meters as the answer. So is the answer complete here? Not exactly. The SI unit of work is Newton meter or joule. How can we define joule then? 1 joule is the same as the work done by 1 Newton of force that displaces the object by 1 meter. So from our current exercise, when we get an answer of 10 Newton meters, we can also say that the force applied is 10 joules. Here's another exercise for you. With the force acting on the ball through displacement, we multiply 20 Newton of force with 3 meters of displacement to get 60 Newton meter or 60 joules as the answer. Now, if the object is displaced and exerted with force in the same direction, the work done by the force is considered positive. When is work considered negative then? Consider a case in which the object is moving with a certain velocity in a particular direction. Now, a retarding force F is applied on the object in the opposite direction. Now, because of this force, the object may not stop immediately. It will stop after a certain distance. Say it stops after a displacement S. You notice that the displacement is in the direction opposite to that of the force. The work done by the force is considered to be negative in this case. Force and displacements are in opposite directions. The work is given by F times negative S, which is negative of F times S. Can you think of a real-life example of positive and negative work? After grocery shopping, the bag you're holding will be very heavy. You're applying a force on the bag to pick it up from the ground. And at the same time, there's a force of gravity acting on the bag. Which of these forces is doing positive work and which one's doing negative work? Easy, as the force you're applying and the direction of displacement of the bag are both in the upward direction, the work done by your force will be positive. And as the force of gravity and the direction of displacement of the bag are in opposite directions, the work done by gravity will be negative.